Good morning, children. Now we are going to see the lesson Organic Nitrogen Compounds in second volume. Okay. So you take your second volume book. There you are going to take the organic nitrogen compounds. Okay. So nitrogen compounds. The organic compounds containing nitrogen are essential to life. For example, amines, the organic derivatives of ammonia, play an important role in bioregulation and neurotransmission, etc. Pyridoxine, vitamin C is a pyridoxine, vitamin B6 is an organic nitrogen compound which is needed to maintain the health of nerves, skin, and red blood cells. Plants synthesize alkaloids, biologically active amines, to protect them from being eaten away by insects and other animals. Diazonium salts find an important application in the synthetic organic chemistry. Nitrogen compounds are the important constituents of explosive, drugs, dyes, fuels, polymers, synthetic rubbers, etc. Those structures are given here. The first one is vitamin B6 and the second one is dopamine neurotransmitter and the third one is histamine, that is dilates the blood vessels. And in this unit, we are going to learn the preparation properties of the and uses of the nitro compounds and amines. First, nitro compounds. Nitro compounds are considered as the derivatives of hydrocarbon. If one of the hydrogen atom of the hydrocarbon is replaced by the NO2 group, the resultant organic compound is called nitrocarbon. And classification. The nitro compounds are classified into two groups, that is aliphatic nitrocarbons and aromatic nitrocarbons. Aliphatic nitrocarbons are in which the carbons are in linear chain, and that is further divided into nitroalkanes and alkyl nitrites. The nitroalkanes are nothing but it is having the functional group as NO2. The alkyl nitrites are the functional group of them are ONO. And aromatic nitrogen compounds, in the aromatic nitro compounds, the compounds having the benzene structure, and that is further divided to nitroarenes and aryl nitroalkanes. Nitroarenes means which is having the NO2 group nitrobenzene, and aryl nitroalkane, the example is CH2NO2, that is phenyl nitromethane. And further, in aliphatic nitro compounds, nitroalkanes and alkyl nitrates are there, out of which the nitroalkanes are again divided into primary nitroalkane, secondary nitroalkane, and tertiary nitroalkane. Primary nitroalkane means the functional group attached to the carbon that in turn attached to only one carbon, that is called primary. And for that, the example is nitroethane. And the secondary one is the functional group, that is NO2 attached to the carbon, and that carbon in turn attached to two more carbon, that is called secondary. And for that, the example is 2-nitropropane. And tertiary functional group attached to that carbon, and that carbon is attached to three more carbon atoms, that is called as tertiary. And for that, the example is 2-methyl-2-nitropropane. Next, nitroalkanes. Nitroalkanes are represented by the formula RNO2, where R is the alkyl group. That general formula is CnH2n plus 1. The nitroalkanes are further classified into primary, secondary, and tertiary nitroalkanes on the basis of the carbon atom to which the nitro group is attached. Next is nomenclature of nitroalkanes. In IUPAC nomenclature, the nitroalkanes are named by adding the prefix nitro before the name of alkane, and the position of nitro group is indicated by the number. For the first compound CH3, CH3, CH2NO2. That is called as 2-methyl-1-nitropropane. And the second one is CH3C with the 3CH3 and CH2NO2. That is called as 2,2-dimethyl-1-nitropropane. And coming to the aromatic structure, with the phenyl group, NO2 will be there. Now, that is called as nitrobenzene. And suppose if one of the substituent is in the ortho position, we can say that one as 2-nitro-1-methyl-benzene. And the next one is 1, 3, 5. There you have to number the substituent, trinitrobenzene. And next is 2-phenyl 1-nitroethane. Okay. Next, we are going to see the isomerism. Nitroalkanes exhibit chain and position isomerism among their own class and the functional isomerism. With alkyl nitrides and special type of tautomerism can also exist in nitroalkanes having an alpha hydrogen atom. For example, nitro compounds having the molecular formula C4H9NO2. They have the following isomers, that is chain isomer. First one is nitrobenzene, CH3, CH2, 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 NO2. This is the linear chain, that is. And in the next one, you have the 3 in the chain and 1 is as the branch. So we can name it as 2-methyl-1-nitropropane. In the first one, 4 carbon are in the linear chain. And the second compound, only 3 carbon are in the linear chain. So there is a difference in the chain of the carbon. So it is called as chain isomer. The next one is position isomer. In this one, the position of the nitro group will be varied. The first one is 1-nitroputane. The second one is 2-nitrobutane. And the third one is 2-methyl-2-nitropropane. In this first one, the nitro group is attached to the first carbon. And the second one, the nitro group is attached to the second carbon. And the third one methyl group as well as one nitro group is attached in the second carbon. So that it is named like that. So this type of position, the change of position of the functional group is called as position isomer. Next is a functional isomerism. Nitroalkanes exhibit functional isomerism with alkyl nitrides. That is 1-nitrobutane and next one is butyl nitrite. In nitrobutane, the carbon is directly attached with NO2. In NO2, it is attached with the nitrogen atom, but in the nitrite, the carbon is directly attached with the or bonded with the oxygen atom. That is the difference. Then the next one is tautomerism. Primary and secondary nitroalkanes having the alpha hydrogen, they also show an equilibrium mixture of the 2 tautomers, that is called as nitro and acid form. Nitro form in which the NO2 is present, whereas in acid form, CH2 double bond, N one side you have O, in the another one side you have the OH group, that is called as acid form. And the differences between the tertiary and nitroalkane do not undergo this type of tautomerism because in this one there is no alpha hydrogen. Next, the differences between nitro form and acid form. Nitro form, those are less acidic, whereas acid form, those are more acidic. And in nitro form, they dissolve in sodium hydroxide slowly, but in acid form, they dissolve NaOH instantly. It decolorize the ferric chloride solution, but in this acid form, it gives the reddish brown color. Electrical conductivity in nitro form is very slow, but in acid form, it is very high. Next, we are going to see the acidic nature of nitroalkanes. The alpha hydrogen atom of primary and secondary nitroalkanes show acidic character because of the electron withdrawing effect of nitro group. And these are all more acidic than aldehyde, ketone, ester, and cyanides. Nitroalkanes dissolve in sodium hydroxide solution to form a salt. Acid-nitro derivatives are more acidic than nitro form. When the number of alkyl group attached to the alpha carbon increases, the acidity also increases due to the plus I effect, that is plus inductive effect. See here in the example CH3NO2. In the first one, only one alkyl methyl group is there. So it is more acidic. Next, you have CH3CH2NO2. So you have two carbon, one methyl, two methyl groups are there. So the increase in the methyl group, the acidity will decreases. In the next one, you have CH3CH3CH. That means the carbon is having two more methyl groups. So if the methyl group, number of methyl group is increases and increases, means the acidic character will decreases. Next, we are going to see the preparation of nitroalkyls. That is the first method is from alkyl halide laboratory method. Alkyl bromides or iodides on heating with ethanolic solution of potassium nitrite, it gives the nitroethane. CH3CH2Br, that is ethyl bromide. If it is treated with KNO2, then the Br and K will combine together and you will get KBr, and the remaining NO2 will go in the place of the bromine. So you will get nitroethane. This reaction follows the SN2 mechanism. This method is not suitable for preparing the nitrobenzene because bromine directly attached to the bromine ring that cannot be cleaved easily. Cleaved means break down easily. Next method is vapor phase nitration of alkanes. That is the industrial method. That is in large scale they are preparing. Gaseous mixture of methane and nitric acid passed through a red hot metal tube to give nitromethane. CH4 plus HNO3 at 675 Kelvin, you will get nitromethane, CH3NO2 with water. Except methane, other alkanes up to N-hexane, which is having 6 carbon atoms, gives a mixture of nitroalkanes due to the carbon-carbon cleavage. The individual nitroalkanes can be separated by the fractional distillation. And the equation is CH3 and CH3, that is ethane. If it is treated with nitric acid at 675 Kelvin, you will get CH3CH2NO2, that is nitroethane 73% and CH3NO2 nitromethane 27%. The next method is from alpha halocarboxylic acid. Alpha chloroacetic acid, when boiled with the aqueous solution of sodium nitrite, gives nitromethane. That is ClCH2COOH. Alpha chloroacetic acid that is treated with NaNO2, sodium nitrite, you will get nitromethane, carbon dioxide, and sodium chloride. And the fourth method is oxidation of tertiary alkyl amines. Tertiary alkyl amines is oxidized with aqueous solution of KMnO4, that is potassium permanganate, to give tertiary nitroalkanes. CH3 thrice CNH2 plus oxygen, that is oxidation with a KMnO4, and you will get CH3 thrice NO2, 2-methyl 2-nitropropane. Next method is oxidation of oximes. Oximes which is having the NOH group. Oxidation of acetyl oxime and acetone oxime with the trifluoroperoxyacetic acid gives nitromethane, that is primary, and 2-nitropropane, that is a secondary nitro compounds respectively. CH3 CH double bond NOH, that is acetyl oxime. If it is treated with CF3COOH, you will get nitroethane. Next is preparation of nitroarenes by the direct nitration. When benzene is heated with 330 Kelvin with a nitrating mixture. Nitrating mixture, already I told you, that's a mixture of nitric acid and sulfuric acid. Electrophilic substitution takes place to form nitrobenzene. That is called as oil of Mirbane. Benzene plus HNO3, you will get nitrobenzene plus water. On direct nitration of nitromethane, metadinitrobenzene is also obtained. The next method is indirect method. Nitration of nitrobenzene gives metadinitrobenzene. The following method is adopted. That is para nitroaniline. Aniline benzene ring with NH2. And if this is treated with NaNO2, that is sodium nitrate, first you will get para nitro diazofluoroborate. Then again, if it is treated with the same sodium nitrate, you will get para dinitrobenzene along with nitrogen fluoride, and a trifluoroboron or boron trifluoride. Amino group can be directly converted into nitro group using the Carros acid. Carros acid is nothing but H2SO5. Otherwise, it is also called as persulfuric acid. And H2S2O8 or peroxytrifluoroacetic acid, CF3COOH, as the oxidizing agent. Next, we will pass on the physical properties of nitroalkanes. The lower nitroalkanes are colorless, pleasant smelling liquids, and those are sparingly soluble. Very little amount will be soluble in water, but readily soluble in organic solvents like benzene and acetone. They have the high boiling point because of their higher polar nature. Alkyl nitrides have the lower boiling point than the nitroalkanes. Nitroalkanes na NO2, nitrates na ONO. Next is chemical properties of nitroalkanes. Nitroalkanes undergo the following common reaction, that is reduction, hydrolysis, halogenations. First one is reduction of nitroalkane. Reduction of nitroalkane has important synthetic application. The various reduction stages of nitro group are given here. Nitromethane, that is converted to nitrosomethane. Then again it is converted to N-methyl hydroxylamine, and further it is converted to methylamine. The final product depends upon the nature of the reducing agent that we are using, as well as the pH of the medium, that is the concentration of H plus ion. Next, nitromethane, in the presence of stannous and HCl, you will get the methylamine. And in the presence of zinc and ammonium chloride, the first one is acidic medium and the next one is neutral medium, and you will get CH3NHOH, that is N-methyl hydroxylamine. And the next method is reduction of alkyl nitrides. Ethyl nitrite, that is already I told you ONO under the nitrite. So CH3CH2ONO, which on reduction you will get CH3CH2OH, that is ethyl alcohol with ammonia and water. And the next property is hydrolysis. Hydrolysis of nitroalkanes. Hydrolysis can be effected using concentrated HCl or concentrated sulfuric acid. Primary nitroalkanes on hydrolysis give carboxylic acid, and secondary nitroalkanes gives ketone. Then tertiary nitroalkanes will not give any reaction. That only given in the tabular column. This is very important, you mark it. CH3CH2NO2, that is primary. If it is heated, boiled with hydrochloric acid, then you will get CH3COOH, that is carboxylic acid, acetic acid with NH2OH. Next is secondary one, that is 2-nitropropane. If it is added with the same boiled HCl, and you will get CH3 twice CO, that is nothing but acetone with N2O and H2O. And tertiary, if you are treated with, if it is treated with the boiled HCl, it will not give any reaction. On the other hand, the acid or base hydrolysis of ethyl nitrate gives ethanol. That is CH3CH2ONO. On hydrolysis, you will get CH3CH2OH, that is ethanol alcohol. Next is halogenation. Halogenation means addition of halogens. Primary and secondary nitroalkanes on treatment with the chlorine or bromine in the presence of sodium hydroxide give halonitroalkanes. That is alpha hydrogen atom of nitroalkane are successfully replaced by the halogen atom. CH3NO2 plus chlorine. You will get CCl3NO2, that is trichloro nitromethane, along with the 3HCl. Next is toxicity. Nitroethane is suspected to cause genetic damage and it is very harmful to the nervous system. Nef carbonyl synthesis, that is CH3CH2NO2. If it is treated with KOH, you will get CH3CHNOOH, and on hydrolysis you will get CH3CHO plus HNO. That is called as nitroxyl azozone. Next, chemical properties of nitrobenzene. C6H5NO2. If it is treated with the stannous with hydrochloric acid, you will get aniline in the acid medium, and with NH4, that is neutral medium, you will get C6H5NHOH, that is hydroxylamine. And if it is treated with again the neutral medium with Fe, iron and water, and you will get C6H5 with NO, that is nitrosobenzene, with the stannous chloride and KOH. KOH means it is the basic medium. Then you will get C6H5NH2 plus C6H5NO, which on self-condensation you will get the azobenzene. And again, if it is treated with the zinc and sodium hydroxide, that too also basic medium, and you will get an intermediate compound like C6H5, N double bond N and C6H5, and that is converted to hydroazobenzene C6H5, NH and C6H5. Okay. Next is electrolytic reduction. And electrolytic, this NO2, nitrobenzene on electrolytic reduction, if it is weakly acidic, you will get aniline with water. If it is strongly acidic, you will get the phenyl hydroxylamine, and by rearrangement, you will get the para-aminophenol. Reduction of catalytic and metal hydrates. Nitrobenzene reduction with nickel or platinum or lithium aluminum hydride to give aniline. That reaction only given here. Selective reduction of polynitro compounds. Suppose if you are taking the meta-dinitrobenzene, if it is treated with NH4 twice, yes, then you will get meta-nitroaniline, that is NO2, and the alternative position we can get the NH2 along with ammonia and water and sulfur. Next is electrophilic substitution reaction. The electrophilic substitution reactions of nitrobenzene are usually very slow, but it is vigorous reaction. The conditions have to be employed. The NO2 group is strongly deactivating the meta-directing. Nitrobenzene, if it undergoes chlorination, you will get metachloronitrobenzene, and the nitration taking place at 373 Kelvin means you will get the 1,3-dinitrobenzene. The same nitration taking place here in the concentrated nitric acid and sulfuric acid, you will get 1,3,5-trinitrobenzene, that is called as TNB. And on sulfonation, you will get the meta-nitrosulfonic acid. Okay. Next, nitrobenzene does not undergo Friedel-Crafts reaction due to the strong deactivating nature of nitro group. Then some evaluate yourself is given. With that, the first class I plan to conclude. Then we are going to see in the next class. Thank you, children.